Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris Nakudin. So I want to answer the question 1. For the question 1, a meaning of differentiation. Differentiation is about a fundamental concept in calculus that deals with finding the rate at which a quantity changes. So it most frequently refers to finding the derivative of a function, and the derivative tells us the slope of the curve at any point. The last one is about it represent instantaneous rate of change like speed in physics. So we go to the technique of differentiation. So for number 1 is power rule. We just use to differentiate terms like x to the power of n. Number 2 is constant rule. Constant rule is the derivative of a constant is 0. Number 3, constant multiple rule. Constant multiple rule is a function is multiplied by a constant and just keep the constant and differentiate it function. For number 4, sum and difference rule. So we use when they have addition or subtraction of the number. For number 5, product rule. Product rule use two functions that are multiplied together. So we use the u and v term. So when it differentiate, it will become u prime and v prime. For number 6 is quotient rule that used when one function is divided by another. So same like number 5, just use term u and v. Number 7 is chain rule. Chain rule is used for composite function, which is function inside another function like f time with gx. So we need to differentiate it. So number 8 is implicit differentiation. Implicit differentiation is used when y is not isolate, which is we can express y directly to the term of x. So we need to differentiate both sides of the equation and treating y as a function of x and solve for dy and dx, dy per dx. And the last one is second derivative. So the second derivative, the function y equal to fx. So the first derivative is obtained by differentiate y with respect to dx, which is dy per dx. So equal to f prime x. So the second derivative can be obtained by differentiate dy per dx with respect to dx. So the process differentiating twice is known as the second derivative.
So Assalamualaikum, my name is Umay Koy bin Khairul Anwar. So today I am going to show you two calculus problems where we need to find the derivative of a function. To do that, we will use different rules from calculus like the logarithm rule, the product rule and the chain rule. So question 2a, this is a logarithm function and inside the log we have a fraction. So we will start by simplifying using logarithm rule. So step 1 is use logarithm rules. We use the log rule for division, which is ln a over b equal to ln a minus ln b, and we will split it into two parts. To each y equal to ln 2x minus 5 minus ln cos with the power of 2 3x. And then now we notice that the second part has a square cosine term. We can simplify it using another log rule, which ln with the ln bracket a with the power of n equal to n times ln a. Now let's substitute that back into our equation, which is y equal to ln 2x minus 5 minus 2 ln cos 3x. Now the function is easier to differentiate. So the second step is find dy over dx. So the first term, which is replace y into dy into dy. So d over ds in bracket ln 2x minus 5, and the final answer will be 2 over 2x minus 5. So the second term, so for the second term, we use the same like the chain rule, and then d over ds open bracket 2 ln cos 3s equal to 2 times d over ds open bracket ln open bracket again cos open bracket again 3s and close. So let's jump into the answer, into the result. It will be 1 over cos 3x times negative sine 3x times 3, and negative 3 times sin 3x over cos 3x is equal to negative 3 tan 3x, because sin over cos is tan, and we will multiply it by 2, which is negative 6 tan 3x, and the final answer will be dy over dx equal to 2 over 2x minus 5 minus 6 tan 3x. So right now for the question 2b, here we see that the function is made up of two parts multiplied together. So this is where we use the product rule. So let's start it by use the product rule, which is dy over dx equal to u prime v plus u v prime. So now let's assign u equal to e with the power of x square and v with the sin x with the power of 3 plus 1. So now we will find the derivative of both parts. So u prime, how to get it is d over ds bracket e with the power of x square and blah blah blah. We will get the u prime, which is e with the power of x2 times 2x. So for the v, we will do the same like how we get the u prime. D over dx open bracket sine s with the power of 3 plus 1, and let's jump into the result. We will get cos open bracket s with the power of 3 plus 1 minus 3x square. So now let's substitute everything into the product rule formula. So it will becomes open bracket e with the power of s square minus 2s close bracket times sine s with the power of 3 plus 1 close bracket plus e with the power of x square times cos s with the power of 3 plus 1 and minus 3x square. So we can factor out e with the power of x square from both terms, and now the final answer will be dy over ds equal to e with the power of x square open bracket 2x sine s with the power of 3 plus 1 close bracket plus 3x square cos open bracket s with the power of 3 plus 1. So that is all from me. Bye.
Assalamualaikum, my name is Lexaris Hazib bin Syasham. You can call me Red. Alright, so today I will be answering question 3. Alright, so let me rephrase the questions. Given xy plus 3x square equal to 2 cos times x plus y minus e to the power of 2y. Alright, so find dy dx by using implicit differentiations. Alright, so first of all, let's divide the equation into two sides, that were left side and right side. So let's settle the left side first. Alright, so for the left side, we should differentiate it first. But first, before that, let's recognize the rule that we should use. Alright, for 3x square, we should use the product rule. Meanwhile, for the for xy, we should use the product rule. Meanwhile, for the 3x square, we should use the power rule. Alright, so let's differentiate it. So the left side, so d over dx times by xy plus d over dx times 3x square. So let's use the product rule on xy. Alright, so d over dx times xy equal to x times by dy over dx plus y times d over dx times x, and we should get x times dy dx over plus y. Alright, so for the next one, we use the power rule on 3x square. So this is the basic one. So 2 will be divided by 3 and we should get 6x, and 2 will be minus by 1. We should get 6x, and for the product we should get x times dy dx plus y. Alright, so let's combine both of them and we should get x times dy over dx plus y plus 6x. So this is for the left side. Alright, for the right side, we still do the same. For this one, we should use the chain rule. Alright, so we apply the chain rule for this one. So first of all, when we differentiate, the first step for differentiation is we should get 2 times d over dx times cos times x plus y minus d over dx times by e to the power of 2y. So then we apply the chain rule. Alright, for information, when we differentiate cos, we should get negative sign. Alright, so differentiate cos x plus y, we should get negative sign x plus y times 1 over dy over dx, and d over dx times e to the power of 2y, we should get e to the power of 2y times 2 times dy over dx. This is for this one. So when we combine it, we should get 2 times negative sin x plus y times 1 over dy over dx minus 2 to the power 2 negative 2 e to the power of 2y times dy over dx. So then, as you can see, there is a bracket here, so I think we should simplify it, and we should get negative 2 sines times x plus y times 1 over dy dx minus 2e to the power of 2y times dy over dx. Alright, so you already done the step 1, so let's go to the step 2. Alright, so we already have the left side and the right side, so let's put it together, and we should get x times dy over dx plus y plus 6x equal to negative 2 sines times x plus y times 1 plus dy over dx minus 2e to the power of 2y times dy over dx. So as you can see, this is the wrong equation. Alright, so let's go to the next step, that will expand the certain sides. As you can see, the right one is kind of bigger than the left one, so let's expand it. So negative 2 sines times x plus y times 1 over dy over dx equal to negative sines times x plus y minus 2 sines times x plus y dy over dx. After we expand it, we should get it like this, and it be x times dy over dx times y times x equal to negative 2 sin x plus y times negative 2 sines times x plus y times dy over dx minus 2e to the power of 2y dy dx. Alright, see, this is the last one after we expand it. So after that, as you can see, both of the sides have dy and dx, so we should collect it and put in one side. Alright, so let's put it on the left side. So we should get x times dy over dx plus 2 sines times x plus y times dy over dx plus 2e to the power of 2y times dy over dx equal to negative 2 sin x plus y minus 6x. As you can see, we bring both of the y and 6x into the back, and the dy dx pairs in the back into the front, so should get this at the ends. Alright, so let's factor out the dy dx. So we factor dy dx, and we should get x plus 2 sines times x plus y plus 2e to the power of 2y times dy dx equal to negative 2 sines times x plus y minus 6x. Alright, as you can see, we already factored it out. Alright, last but not least, we solve for the dy dx. As you can see, x plus 2 sines times x plus y times 2e to the power of 2y times dy dx. We should bring the x plus 2 sines into the back, so in up front they are times, we have to multiply. So if we bring it to the back, we should divide it. So at the end of the sessions, the answer is dy over dx equal to negative 2 sines times x plus y minus x over x plus 2 sin x plus y plus 2e to the power of 2y. So this is the final answer. Alright, I think that's all from me. Thank you.
My name is Muhammad Arifuddin bin Muhammad Shukri, and I would like to explain the question 4. For the question 4, is the question asked to differentiate to estimate the value of square root 9.03 plus 1 over square root 9 over square root 9.03. So first we need to define the function. So let fx equal to square root x plus 1 per square root x. Now we want to estimate the function at x equal to 9.03, a equal to 9, dx equal to x minus a. So we can calculate by using calculator, and we got the answer is dx is 0.03. For the step 2 is to find the derivatives. So we need to differentiate fx equal to s 1 to the power of 1 per 2 plus s to the power of negative 1 per 2. So we f prime of s, so we got 1 per 2 s to the power of negative 1 per 2 minus 1 per 2s to the power of negative 3 per 2. Now after we got that, we evaluate f to the prime of s at s equal to 9. So f prime of 9 is equal to 1 over 2 square root 9 minus 1 over 2 square root 2 times 9 square root 9. Okay, then we simplify that, and we got 1 over 6 minus 1 over 162. After that, we need to get the common denominator of it. So 1 over 6 is equal to 27 over 162. So f to the prime of 9 is equal to 27 plus 1 over 162. We calculate that, and we got 26 over 162. We simplify that, and we got 13 over 81. After that, we use the linear approximation formula. Fx is almost equal to Fa plus f prime a times dx. So f times 9.03 almost equal to f9 plus f prime of 9 times 0.03. F times 9 is equal to square root 9 plus 1 over square root 9. We simplify that and we get 3 plus 1 over 3, or the final answer is 10 per 3 or 3.333. So for the f prime 9, the final answer is 13 over 81 or 0.1605. We got all the calculation and we just put that back into formula, and we got the final answer is 3.3378. That's all from me.